In this video, I'm going to find the general solution of the ODE y prime prime minus 4y prime plus 5y is equals to 0. Now, this ODE that we are given is a second order ODE with constant coefficients. It is of the form a2 multiplied by y prime prime plus a1 multiplied by y prime plus a0 multiplied by y is equals to 0. To find the general solution of this ODE, we first have to find the auxiliary equation, then find the roots of the auxiliary equation. The roots will determine the nature of the general solution that we have. The auxiliary equation of this equation here is a2 multiplied by m squared plus a1 multiplied by m plus a0 is equals to 0. So comparing these two equations here, look at the coefficient of y prime prime. Here we see that it's an a2, here it's a 1. So we have a2 there is a 1. Look at the coefficients of y prime. Here it's an a1, here it's a minus 4. So we have that our a1 there is a minus 4. Look at the coefficients of y. Here is an a0, here is a 5. So we see that our a0 there is a 5. Substitute the values of a0, a1, and a2 into this equation here. So we would have that the auxiliary equation of this equation is m squared minus 4m plus 5 is equals to 0. I can try to see if we can factorize that, try to find numbers which when we multiply them they give us a 5, when we add them they give us a minus 4. We can't find such numbers, so we cannot factorize this part. If we cannot factorize that part, then we would have to use the quadratic formula. Minus b plus or minus square root of b squared minus 4ac divided by 2a. So using the quadratic formula, we would have our m is equals to 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 divided by 2 times 1. Under the square root sign there, we're having a 4 squared, and that's a 16. 16 minus 4 times 1 times 5, that's 16 minus 20, which gives us a minus 4. Square root of minus 4, it will give us 2i. So we would have in the numerator there, we would have 4 plus or minus 2i. Then when you divide it by the 2 there, we would have that our m is equals to 2 plus or minus I. So what we are having there is the roots of the auxiliary equation for this ODE. They are complex conjugate roots. When we have complex conjugate roots, m is equals to a plus or minus ib. The general solution is exponent of ax multiplied by c1 multiplied by sine of bx plus c2 multiplied by cosine of bx. So comparing the roots that we have there, 2 plus or minus I, with this one here, a plus or minus ib, we see that our a there is a 2. Our b, the coefficient of the I, is a 1. So substitute wherever we have a in this equation, we are going to put a 2. Wherever we have a b, we are going to put a 1. So we have the general solution there is exponent of 2x multiplied by c1 multiplied by sine of x plus c2 multiplied by cosine of x. So what we are having here, this is the general solution of this ODE here.